Hello again. In this lecture I'd like to talk about not a specific encryption algorithm, but what are called modes of usage for encryption algorithms. Okay, so you might imagine we talked about AES. The way you might use AES is you just take each block in the plain text, encrypt it using the same key, and output the result. Okay, and that particular mode of usage is called electronic codebook, or ECB. The problem with that is each block in the plain text, or if you have identical blocks in the plain text, the result is going to be identical blocks in the ciphertext. So for example, if you look at the first picture here, you'll see that all the blocks in the background are all going to be identical. And so the result is going to be that we have in the background identical ciphertext blocks. And it didn't really hide the picture very well, right? Because you have plenty of regularity left in the ciphertext to be able to figure out what the original picture was. And so what we would like to do instead is to deal with this problem by having a process by which identical text in the plain text, identical blocks in the plain text don't yield identical blocks in the ciphertext. Well, how do you do that? Well, one way you might do it is to sort of effectively randomize the plain text blocks before they're encrypted. Well, cipher block chaining is a way of doing that. And what you do is you take each block in the plain text and you XOR it with the preceding ciphertext block. To get this started, you have what's called an initialization vector, which is just a randomly generated string. And then each block in the ciphertext is going to be the result of something which has been randomized before it's been encrypted. And this takes care of that problem. Now, there are still some issues with cipher block chaining. For example, if someone is watching the encryption over time, they can look at say the original encryption, and now you have a new encryption of the same text with some changes. They can see where the first change was made or which block it was made in, because everything is going to be the same in the two encryptions up to that point, and then everything's going to differ after that. I don't know whether that matters, but it's the kind of a problem that cryptologists worry about. Another one is if you have two ciphertext blocks under this scenario, which are the same for whatever reason, then you can XOR those together and get some information about the plain text block. Once again, that probably is not going to give you much information, but it's an issue to be concerned about if you're worried about those kind of things. Okay, so what I've just been talking about are called block encryption modes. And the idea there is you take your plain text, encrypt it, and you want to be able to, of course, recover the plain text when you do decryption. Sometimes you use these block encryption algorithms for a different purpose, and that is to generate essentially what appears to be a random string of bits. And these are called key stream generation modes. So the idea here is you use an encryption algorithm basically as a pseudo-random number generator. And here's an example of that. It's called a cipher feedback mode. The idea is you just feed in bytes of text, arbitrary text. You shift those onto a register, encrypt the result, and then output part of the output. The upshot here really, or the point of this, is that for really good modern encryption algorithms like AES, the output is supposed to look random. It's not random, of course, but it appears random. And so what you're generating is a random appearing stream of bits in a way that's reproducible. And so you could use this, for example, as a key in a one-time pad. And then anyone who knew the input and the algorithm could generate this at the other end to generate the same key to extract the text. Okay, so what have we said? Well, a naive use of encryption would use the same algorithm for each block, but that preserves too much regularity. That's called electronic codebook, and so that's not often used. And so the idea is to come up with some scheme which will hide that regularity in the output by randomizing the blocks before you send them through. And CBC is a good way to do that. Those are called block encryption modes. We also have another use of encryption for key stream generation modes. And the idea there is to be able to generate a random appearing stream of bits. And you can use any modern encryption algorithm with any of these modes to do either of those two things. Thanks.